Welcome to Baozi Training Leetcode solution. If you want the best mock interview experience in North America, feel free to check us out at baozitraining.org. Moreover, if you would like to subscribe to the latest tech interview news, feel free to subscribe to our WeChat right here. Today we're going to talk about another very classic problem, which is called merge k sorted list. So given k, here is basically giving you an array of k lists. So each list is sorted, and then they want you to merge all the k sorted lists together. So there are, in general, three ways to solve the problem. The most common way to use to solve this problem is by keeping a minimal heap, assuming you're sorting a ascending order. So when you have the minimal heap, all you need to do is keep a minimal heap size to be size of k, and then you keep just popping out the smallest and then append it to the final list. And then you, because this is a linked list, you know the next pointer, so you just add another next pointer, add the element to the list, to the heap that requires a log k complexity to heapify this heap. And you just do this for all of the elements. So assuming there's k lists, and then each list contains n elements, roughly speaking. So with a heap, the time complexity will be in the order of n will be there's this many elements times log k. All right, so let's code it up this method, and we'll talk about the other two methods later. Okay. Some validation checks. Not the best practice to return null. You should return empty, but here just do this for now. Okay, so what I'm going to do is I will have a queue of so for priority queue is so first I want to have this many of size. Okay. Comparator of just a node. Here there's a method called compare. Here we're just assuming they're not now. We can always compare this node comparator, right? So there's no null element added to the heap, so we can just assert this. K element added to the array. not equal to now, so I want to add each of the element to the heap. Now, so that could be less than size of less than k, so that, but that's okay. So I just need to get each of the there. So while as long as it's not empty, so okay. Dummy, so that's at the end. All I need to do is return this while heap is empty, not empty. What we can do here is pull this, and next want to point it out to this guy. Current will point it out to this guy. Heap dot offer this guy dot next. Just want to make sure not equals to now, then I will add it. Okay, so this is basically the loop. Let's check the code super quick. So we did some null validation, we got the size, we have this, so the comparator is the increasing order, and we push all the list ahead into it. We got the dummy. So let's see if it works actually correctly. You pull a new one out, your current .next points to that guy, current pointed to that guy, and then if that guy is next not equal to now, so you just put out the next into the heap, and then you just keep checking on the heap. Okay, it looks correct to me. No interface expected here. What does it mean? So I'll extend the comparable. Is it an interface or a comparator? Is it an interface or a, I think it's oh, maybe is I think it's a, yeah, sorry, it's interface. It's an interface. Oh, it's fine. Okay, so like I said, this is a kn log k solution. So the other two ways, first way is basically to just keep merging two. So if you keep merge 2, then the time complexity will be n plus 2 n plus kn. So if you still remember how to sum this up, it will be 1 plus 2 plus k. That will be n times k divided by 2. So in that case, it will give us a n k square solution. So if you actually code it up, you will find that there's actually going to be time limit exceed exception, so it won't pass here. Another very clever way to solve this is just like merge sort. So you have kind of a divide and conquer. You just keep merging. You just keep dividing it until it is itself, and then you keep merging two together. So in that case, the problem can be solved because there's a k list, so it can be solved as 2 times k divided by 2, and each of time you have to merge n times k elements. So this will basically give us onk log k solution. This is actually the best because it does not require any extra space, and the time complexity is the same as using a heap. So you will see more detailed code in my explanation, so which I will post it later. But just remember, this is the best way to implement it. And then this for complexity perspective, and the first one is the most easy common way to use whenever you have an order type of thing you want to use a heap. Okay, thank you guys for